Hi, welcome to this Open Security Summit session in January 2024. And we have Saber here, who's going to talk us about how to perform threat assessments the right way. So over to you, Saber.
Thank you so much. Yeah, today I'm going to talk about performing threat assessment, which is something I'm doing really passionately for the last, I don't know, years, 5 years, 6 years. I have around 10 years of experience, most of it in cybersecurity. I worked mostly in application security due to my background also as a software engineer with various companies across Europe, including banks and automotive sector and so on. So the title is a little bit intriguing. I mentioned the right way. It doesn't mean like there is a right way and wrong way, but it's simply trying to translate most of my experience and lesson learned from what I see companies doing. So let's see. A little bit of a context here. So cybersecurity is a really interesting field, and it only gets more and more interesting over time. If we see what's happening in the last years, we only see that the number of incidents is increasing, but also the attack vectors, attack scenarios are getting more complex and more, interesting. So there is definitely a lot more demand in terms of skills, in terms of tools, and so on. On the other hand, when we talk about also compliance, not only in Europe, but all over the world, more and more governments are putting additional pressure on larger companies, especially critical infrastructure, to ensure that there is baseline security assurance ensured. So we see a lot of demand, not only from the number of incidents, but also from compliance perspective. On the other hand, what we see is that organizations, a large part of organizations are still understaffed and under-budgeted when it comes to cybersecurity. This is according to ISACA cybersecurity report in 2023. But also what we see is that organizations takes a lot of time to fill in the open roles for cybersecurity. So even if you have the budget and even if you decide to hire and you decide to invest, you still are not, it's not easy to get the right resource the right time. So you really need to find more creative ways to perform threat assessment and to identify threats before they hit us. And we need to optimize our effort and budget and resources. Also trying to start with the final goal in mind. So getting a citation from the first CISO in history, Steve Katz, who passed away last year, is him. So he said data security, information security, and information risk is a business risk issue and not a technology issue. Unfortunately, many organizations keep looking at it as part of IT infrastructure internal issue. So according to Steve Katz, technology doesn't have risk. Security doesn't have risk. It's the business that have risk. So we need to look at it from business perspective with business goals in mind. All right, moving on. Performing threat assessment basically occurs in 3 steps. The first step is to identify the threats depending on the context, on the scope, and so on. And then we perform the risk assessment. And then obviously after we identify the threats and we assess the risk, then we take action either to remediate or to mitigate or simply to avoid the risk completely, cancel the project, whatever the scenario is. So starting with threat assessment, threat identification, that also include multiple areas. The first one I would say is the asset inventory. You cannot really properly protect what you don't know. And this is an area where a lot of organizations still struggle with. So we have the right tools, we have the right skills, but then at the end of the day, we don't necessarily apply to the whole scope or the whole applicable type of assets. And then we end up getting attacked or breached or compromised via a vector which is simply not known to IT team or DevOps team. So it's really important to attempt as much as possible to keep the asset inventory up to date and accurate. When we say asset inventory, a lot of companies simply think about physical assets and laptops and so on, but this is really also key to performing threat modeling and threat assessment, because we want to go into higher level of granularity when it comes also to data assets. Moving on, then we have to identify potential threats. And I highlight the word potential here because we still don't know whether these threats are really applicable, are relevant, are true, or not, maybe false positives. And here we combine both manual effort, but also automated scanning tools. And then once we have all the assets and with the right properties and the right attributes, and we have all potential threats, some of them are applicable, probably, probably not. We don't know yet. We don't have enough context. So then we go into vulnerability management, where we get a combination of all information from internal and external environment. So we can conclude whether certain vulnerabilities need immediate attention, certain vulnerabilities can simply be dismissed, and certain vulnerability can be tolerated, but only for a limited amount of time. Going to the asset inventory, as I said, how can we create a proper useful asset inventory? There are a number of questions that I'm here just suggesting some of them. It's just, we need to ask what kind of asset do we have? And when we say assets, it's anything that is worth protecting. And it doesn't only include physical items or premises, but it also include, when I say everything worth protecting, it include APIs, it include secrets, it include API keys, it include SSL certificate. All of these are actually assets. And from my experience, when you ask many companies who are already certified ISO 27, for example, they use a narrow definition of assets, and they only have an inventory of IT equipment, maybe infrastructure, maybe servers, maybe routers, but IP cameras, but actually data assets is probably one of the most important ones. And after we identify these data assets, we also need to identify the right categories, because not all assets have the same properties and same attribute and same impact on cybersecurity. Ideally, we should also have an ultimate owner for each asset. We cannot just say per asset, one or two, but per at least per category. So certain asset automatically falls into the ownership of someone. And that person needs to be responsible for ensuring that certain properties are respected, such as confidentiality for certain data from customers and so on. And yeah, that's the final one. So the properties that apply to certain assets. I'm just providing here a list of items that can be used for the asset inventory. So also human assets, including employees and customers and visitors. At the end of the day, when there is an incident, it's not only going to impact financial posture of the company, it might also impact human asset, it might impact the employees or even visitors. And usually a human is the most important factor at the end of the day. So physical assets, usually this is kind of implicitly taken care of by many organizations, even though it's not the most directly relevant to our presentation today, but still, when it comes, for example, to physical security and access control, this is an area where there is some kind of a joint between application security and also, at the end of the day, you properly protect your application and infrastructure, but you leave the door open to it, and maybe everything you did is not that relevant anyway. Third, we talk about intangible assets, and that include brands. And brand is actually difficult to evaluate the monetary value of a brand, but we evaluate it by what is the impact of an incident on the brand. And then when we assess the loss in revenue, when we assess the loss of missed opportunities, that can be used to assess the actual value of a brand. APIs, as I mentioned, now there is a proliferation of API almost everywhere. A lot of companies simply make use of third-party services which have APIs which are not necessarily properly configured. So we do have API in many applications that some people don't even know they have APIs. But unfortunately, if we don't properly manage these APIs and we don't really track them, we don't really check their, how to say, currency, that they are up to date, the software behind it and so on, that's also a problem. Domain names and source code and so on. Finally, the fourth category is information asset, which I was focusing on here, and this is a good joint with application security. The kind of attribute that we can map to a number of assets include, as I mentioned earlier, the owner and custodian. Owner is actually the person who is responsible for the governance, but custodian is usually the person who allow or confirm that someone can access or cannot access and so on, as the name suggests. The value here is something that we can estimate. It's not necessarily only the monetary value, but it's more than that. It's if that asset is impacted, how our revenue as an organization is impacted. Security properties, it could be that we can say, yeah, the source code is an asset, but at the end of the day, it is open source, but we still want to ensure its integrity is protected. So it's not like we don't want to disclose the code. We are okay to disclose it, but we want to ensure what property exactly is or need to be protected. And then also when it comes, for example, to compliance and regulations such as GDPR, it's good that certain data is labeled, including, for example, personal data, financial data, healthcare data, and so on. When it comes to API management, I would say this is maybe a continuation of asset inventory. I wanted to focus a little bit on it more because, as I said, with the proliferation of APIs, a number of organizations don't necessarily track all API in a single source of, with a proper governance. So it's important that we confirm that all APIs have a consistent structure, consistent security posture, and that, as I said earlier, this is one of the main vectors of attack, and the company get breached via API because it's simply easier to exfiltrate data and to impersonate users or machines and so on. So I wanted just to here to provide a reference from Nginx, which includes some of the golden rules, and at least one of them is definitely related to security at scale, but also monitoring and versioning and central governance. Now, trying to move into how can we do threat models? There are a number of frameworks. As you suggested earlier, the previous one was leveraging generative AI for performing threat models using Stride. Actually, one company in the US has extended Stride with one additional, element, which is lateral movement, to extend the use of Stride beyond application security. I assume that most of the audience, being in cybersecurity field, might be already familiar with Stride. Spoofing is for impersonating a user. Tampering is related to integrity, when you can just manipulate the data and use it for malicious purpose. Repudiation, if a user or threat actor can deny that something occurred on behalf of a user. And information disclosure related to confidentiality as a property. Denial of service is related to the availability. And elevation of privilege is related to authorization. So if someone can get higher level of privilege compared to the regular user, then that's also a kind of an attack vector. Now, how can we use this in order to identify all the threats? Now, we have identified all the assets. We have estimated their value and the owners and applicable rules and labels and so on. And we have identified a category of threats. At the end of the day, we as security professionals, we learn a lot about incidents. We follow the news every day related to cybersecurity incident and what kind of attack vectors and techniques are being used. But who is making the product? The developer? and the developer focuses on the functional aspect of the product. And that's why I wanted to check that how can we combine the skills from cybersecurity professionals with the knowledge of the developer to ensure that we have a really good outcome from threat modeling. And I wanted here to use the analogy with IKEA effect, which is often referred in marketing, is that it was observed that if the end user is involved in creating the product, then they value that product even more. A problem that I often notice and observe in our field, cybersecurity, is that cybersecurity professionals tend to criticize the work of a developer, which they are passionate about, and that create a bit of a division between security team and developers. So instead, what I suggest is that security professional can leverage, for example, the community of security champions. I already saw that there is also in this summit some dedicated talks about it, so don't miss it. The community of security champions can be a good option or a good approach to merge that gap and to promote the collaboration between security teams and developers. And that means if the security professional know very well all kinds of attacks, but doesn't necessarily know all the details of how certain product is implemented, that is properly and very well complemented with the knowledge of the developer. So if the developers and the security professionals sit together, leverage the IKEA effect, so then the developer themselves, they will feel like they're involved. They are part of the not only the product design and implementation, but also uh, implementation of the defensive measures. And that makes the developer value his product even more, not only from functional perspective, but also from security perspective. Another way to look at it also, if it's maybe complementary to this, is that the developers are kind of programmed, maybe are used to think mostly about the use cases. And that is directly related to functional requirement. So you get some kind of, how to say, list of requirement. The application here, I'm just taking an example of, for example, payment application or banking application, but you can think of it of any application that includes some credit that you need to maybe accumulate or transfer between multiple users. So let's say this is a mobile application or even web application, and the end user is supposed to check his balance and is supposed to enter a number that can be used to transfer certain credit from one user to the other, but also the whole application should be upgradable, let's say. But for each of these requirements, you can also think of it on the other side. If you are a security professional trying to come up with a threat scenario, you can think of what can go wrong. So if the user can check his balance, can he only check his balance, or maybe he can also check the balance of someone else? The fact that the user is authenticated is not enough. You really need to make sure that he's authenticated and able to only check his information and only his information. Also, when we talk about functional requirement, there is a reflex here also from security perspective. If you can enter any value, is there an input validation? Can you only enter expected value, or maybe you can enter a negative value? If you are only expected to send a positive amount, if you send a negative amount, it's similar to as if you received an amount, actually. So before we go to any processing into the backend and so on, the malicious input should be blocked as early as possible. And as I mentioned earlier, when it comes to requirement related to software update, is it possible that someone else can do that software update? How can we prevent it? Can we enable, for example, secure boot? Is there a signature verification before accepting the PK or even a firmware for IoT objects and so on? So we need to ensure that developers not only think about functional requirement, but also think about what can go wrong for each of potential requirements. And yeah, now moving to vulnerability management, I think there was a very good presentation from Francesco from Phoenix Security. where he mentioned all this, how to say, analysis on a number of commonly exploited or actively exploited vulnerabilities, and mapping them per software operating system or per, for example, environment and vendors, and there are a number of criteria. And I love this. To be honest, the way I love it is because I see many organizations makes the mistakes of taking, for example, CVSS as a single criteria for deciding which vulnerability need to be to get fixed and when. You have, for example, 3 months to fix, I don't know, high severity, or 6 months to fix medium severity. The mistake here is that developers who are already overloaded with work, they also need to ensure that maybe many of the vulnerabilities they have to fix are simply not exploitable. And even if they're exploitable, there is a precondition for them to be exploited. So you need to be authenticated, for example, and so on. So at the end of the day, as I mentioned in the beginning of the presentation, it's all about business risk. So if you already are having an understaffed security team, and you also overwhelm the development team by asking them to fix everything, then you're doing it wrong. And in my opinion, the best way to merge all the findings from manual input, as I mentioned earlier, from threat modeling, but also automated input, is to have them also mapped with assets and with values and with right context, so that you can more or less estimate how many vulnerabilities with which level of severity and what score of EPSS, for example, exploit score, to evaluate what is the actual risk on your product. And is that product really worth that investment to get fixed as early as possible or not? So that's the real question. And with that, I want to provide a bit more context on how vulnerabilities can be mapped. So the National Vulnerability Database, used with all the vulnerabilities with CVSS and other kind of scores, and also the properties, it tells you if this vulnerability is related to confidentiality, or if it's remote code execution, or if it's maybe a inefficient regular expression that might lead to a denial of service, and all of that. So at the end of the day, if we make one level of abstraction, we end up finding the root cause of that vulnerability. And that is tracked in Common Weakness Enumeration database. And then above that one level, we also have the CAPEC, which is also a database for attack pattern by MITRE framework. And then above that, we have the MITRE attack framework, which include the attack technique and tactics from mostly APT, Advanced Persistent Threat. So looking at this, we can say that having thousands of vulnerabilities doesn't mean that you are behind and that you are gonna die tomorrow or that business will go bankrupt. It doesn't also mean that you can simply ignore them safely. You really need to be very clever and find a way to identify the really vulnerability that will impact you right now and it's probably are already compromised, and which vulnerabilities simply do not even deserve to be looked at. And with that, we can also look at one step further. So by doing the threat assessment internally, by doing threat modeling, you also map all of these vulnerabilities into your products, into your assets, into your business objectives. And then you can already make an assessment of what need to be fixed when. Also on the other side, by taking into account threat intelligence and also, for example, threats related to supplier. If you have suppliers to whom you delegate critical part of your development, then it's maybe a good idea to assess their security posture. What if one of your suppliers is compromised? We see already more and more often since SolarWinds that supply chain attacks are also increasing dramatically. So instead of going into a large organization with a mature security program, now threat actors are simply focusing on less mature organizations, which are also trusted by these large organizations or even governments or banks or critical infrastructure. But at the end of the day, they don't do everything in-house. So they might outsource certain critical activities. They might have a trust relationship with third-party organization. We also saw this with Okta recently, where the compromise was simply due to, we saw it also with Movit last year, where the impact on a number of organizations was simply due to third-party risk assessment, which was not to the expectation. Now, I think this is maybe the most important part of this presentation, because at the end of the day, what I talked about is only identifying the threats. And in order to make the right decision, you need to really map those threats from the internal terminology used by security professionals into the business terminology, which is what is the risk on the business, what is the expected loss. How can we know that we are doing risk assessment in a proper way? It's actually based on one question, maybe two here. So where and how much shall we reduce risk, and at what cost? Depending on our risk appetite, depending on our risk acceptance, how much should we spend in order to reduce the risk by how much? And the main two inputs are likelihood and impact. And I'm against simply saying likelihood times impact. It's not like you multiply two variables and you get something, you put it in a risk matrix, because at the end of the day, the risk matrix doesn't really help you answer this question. By putting certain threats into risk matrix and saying it's likely or unlikely or highly unlikely, or if it's critical or high or medium, at the end of the day, how can you decide to reduce the risk? You are making a number of assumptions by putting these threats into a risk matrix, and that end up distorting the information. And by doing that, you also end up making the wrong decision. So let's take an example. If we ask the audience, what is the average weight of an adult elephant? Without looking into Google, without putting an elephant into a scale, just a wild guess. And this is what we, security professionals, have to do almost every time we do a threat assessment. We have to make a wild guess. But at the end of the day, you cannot just say, maybe an elephant is around 10 ton or 100 ton or 1 kilo or 20 kilo or whatever. You provide a value with more or less a range, right? So more or less 10%, 20%. So the actual right way to answer this question is the same that we use also in security. It's that we need to have an estimation of what is the actual threat with a level of confidence. And that level of confidence, let's say here in this example, it's 90%. So if we have a level of confidence that maybe if there is an asset or a system that is compromised, then the loss will be at least 10 million or at most 200 million. So that means there is also 5%, it can be less than 10 million, and there is also 5%, it can be more than 200 million. But at least then, by doing a simulation, what we call Monte Carlo simulation, with all the identified probability of threat occurring, then you can say, like, in the next year, if I spend X amount of money with implementation of certain control or buying a certain external tool or maybe redesigning the product, how much we're going to spend and how much that spending will reduce the risk. And that by using quantitative methods like this, we really make a much more accurate decision. This is...
Saber, can I just add a quick comment here?
Of course.
So I'm a massive fan, by the way, of Monte Carlo and stuff like that, right?
Yeah.
One of the problems I always had was how to scale the data creation into it, but more importantly, how to scale the feedback loops, right? So, so my thinking now is that now that we have the ability to, for example, use Gen AI and bots to create and massage some of the data, I think we have a way to make it work. Because if you think that you have a sequence of prompts that lead to the creation of the data that you have in here, where you still work on real world data, but in a way, we don't have to build a massive engineering pipeline to start to
Yeah.
create and produce this. And we almost can democratize the access to this kind of thinking where it becomes a lot more real. And imagine you being able to even use this if you deploy this tool, if you apply this fix, if you do this particular activity, this is the impact on the curve, right?
Totally. So the thing is, there is maybe if I can repeat your question, is like if we want to leverage, for example, AI or big data in order to make the right iteration or decision for every risk. Problem is that
but
if
just
we,
to speed up that loop, right? To make sure that we don't have a lot of engineering required to get to here, because that was the challenge I had in the past, was how to get to here in a way that's iterative.
I hope I understood it, your question. So in my opinion, the idea is like, if you decompose the scenarios too much, then you end up in another type of problem, because at the end of the day, what you see here in this table is high-level description of scenarios, database access, physical access, man in the middle. So these are not individual threats, like as you mentioned, that these are high-level threats, but they are mapped to what I mentioned earlier. Each vulnerability might impact an asset. It might impact the asset in a certain specific way. For example, with availability, depending on the property, it might impact it with authorization, elevated privilege, and so on. So we need to do all of that so that we map all findings. And I highlighted the word potential for a reason, because we still don't know yet if it is relevant or not. But by combining them all, we put them in one of these scenarios, and then we apply the quantitative methods and the Monte Carlo simulation. But still, we shouldn't overdo it, because if we decompose too much, then you end up operating additional iteration for every subsection, and that's not something you can, keep doing on the long term without any significant gain, let's say. So at the end of the day, what the senior management want to know is not that a specific vulnerability is mitigated or not. It's like a specific scenario, whether it is via this asset or that asset, whether it is via this channel or the other. But the most important is that you have higher level scenario, and those should not be like more than a dozen or maybe 20 scenarios, but at most, I'm saying. There you can do the Monte Carlo simulation at higher level. But in my opinion, and also what Douglas Huber say in his book, is like you should decompose, but not too much. You should decompose only if there is added value. But by decomposing, and if you have additional data, but because certain scenario, for example, let's say supply chain attack. If you put all type of supply chain attack in one category, yeah, it's acceptable. But in many cases, by decomposing supply chain attack into software supply chain attack and also operational supply chain attack, like there is an employee whose account is compromised and so on, that's one category, while software supply chain attack is related basically to software composition analysis. So they are both in the same category, but by decomposing them, you have more inputs, and then you can refine your Monte Carlo simulation, and you can also refine your information for return on investment for specific scenario. There, it's useful. But in many, many other cases, if you decompose a scenario or a category into individual scenarios, then you end up wasting too much time in the risk assessment itself. And that time might be more useful spending it in, something more useful. I hope that answers.
Yeah, cool. Thanks.
Thank you. Yeah, so I'm really a big fan of this because, as I mentioned, unfortunately, many organizations use load methods, which even though the threat is properly identified using the right tool and you have the right skills and team involved in the process, but then it's not always easy to demonstrate to senior management that this threat need to be addressed or should be addressed, and what is the right argument for it. How much money we should spend for which solution, or for which maybe external tool, commercial tool, hiring someone, changing the design, and so on. Now coming to risk treatment, I'm not just gonna say the regular solution you have to avoid or mitigate or whatever. I'm just giving some high level lesson learned. If you are focused on the smaller picture for each threat scenario, then in many cases, yeah, there is a threat, you have to fix it. There is a problem, you have to fix it. Yeah, there is a secret, you have to remove it. But at the end of the day, maybe it's good to focus on the long-term improvement. Starting with attack surface. Do you really need all these APIs? Maybe you can limit your exposure, not by limiting the number of APIs, but limiting the exposure of the API, maybe to certain customer using zero trust. Maybe to for example, when it comes to SSL and TLS, make sure that you don't necessarily keep it with the lowest level of how to say security simply because you want to accept the highest number of customers. In many cases, if you keep doing that because you don't want to miss on the revenue, then users will simply never update their devices. So in many cases, you have to really make sure that your APIs and your systems are only accessible with secure ways. And that will end up limiting your effort a lot more and limiting also your risk. So instead of mitigating certain risk, you simply remove them, avoid them. That's another way of saying it. The second lesson learned is focus on resilience. At the end of the day, there is no system that will never fail. But can you fail safely? Can your system recover after it fails? And here I am implicitly referring to security chaos engineering, because if, for example, what we know Netflix has been doing since many, I think 2010 with Chaos Monkey, is that the system is built with resilience in mind. It means that if there is a failure in a system, before any manual intervention, the system will have self-healing feature. It means that the server knows that you have one direct target, but also one backup target. If the data cannot be retrieved from the main source, then there is an incident. But in the meantime, the system will adapt in certain way that the end user will not see any error or any problem at all. The service needs to be performed, how to say, operational at all times. And internally in your infrastructure, you design it in certain way that if there is an issue, if there is an incident, the system has to adapt. And the final lesson learned, let's say, is to leverage reference architecture. Giving too much freedom to developers, you can use any code, any tech stack, any solution, and so on, means that we as security professionals end up being unable to catch up with them. So it's good that we choose what kind of technology can be used, but how exactly. So for example, within AWS or Google Cloud or Azure, you can create, if you are using, for example, a mobile application or a web application or whatever, this is the way to do it. We provide kind of by scratch that are secure by design and by default. So if you want to use, for example, a web application, you can use AWS Simplify. You don't need to use, for example, WordPress and host it on EC2 machine and so on, because you need to ensure the EC2 machine itself is secure. If you are using container, you need to also scan these containers. Why? Maybe you can do it all by leveraging the managed services by using, for example, AWS Amplify, or by using serverless application or something like that, that reduces the operational effort. And this is just one example, of course, but having reference architecture, it means that before we even do any threat assessment, the developer already start from something clean, and baseline security is already assured. I hope I didn't take too much time, so that's basically it from me. I don't know if there is any additional questions.
I don't see them a lot on the chat. The main one I have is a lot of the stuff that you talk about, which is really cool, is also a lot about that sort of the business logic layers, right? Where you try to understand more how the app goes.
Yeah.
And how much have you got into actually trying to get, for example, visualization, like the threat models, the sort of the more originally non-security assets that we can get, so that we can use them to understand what's going on, right? To really understand how the app works. Because I feel that tends to be a gap where a lot of the times even the developers of the apps don't fully understand how everything really puts together, right?
Yeah. I think a good way to answer your question is to refer to a commercial solution. Maybe it's also a good coincidence that is, I think Iris Risk is also sponsoring this event, and they have a community edition of their solution, which any developer can already immediately use. So to visualize what kind of threats are applicable to certain technology, so you simply have to draw an infrastructure from cloud, for example, and you say I have S3 buckets connected to this, I don't know, EC2 machine, and I have maybe, I don't know, container technology. I use secret database and so on. And then by simply drawing that, the solution, it will identify all kind of threats that are applicable to each of these services. And then the developer looks at it and they simply can dismiss certain vulnerabilities because they are not applicable, or they can track them. And I think that's one of the best solution I saw so far, at least. Unfortunately, it doesn't go as far as external environment or suppliers, at least as at the best of my knowledge. But I hope that's maybe the best answer I can provide, because maybe what you mentioned is a good idea, that we try to look into something bigger than just application security and threat modeling, including supply chain and awareness, human factor, and so on. And that's why I started with the focus on business risk, because at the end of the day, we need to always keep the big picture in mind. If we only focus on CVSS or business logic or human factor or supply chain, all of these have inconsistent metrics. They are very complex already by themselves, and trying to funnel all that information to senior management and make a decision, it's not easy. So we really need some kind of observed way, similar to what Francesco did with vulnerabilities, but on a higher level, on a larger scope. Hope that answers.
Yeah, cool. No, and I think that that area is always going to be, in fact, that intersection, right?
Yeah.
Is always going to be a source of issues. That I always find that the areas that teams struggle to test, and the areas that they have bugs, the areas that you're going to find lots of security vulnerabilities, because they're just hard to test, and also hard to do regression.
Yeah, true. But even more, because you're lucky if you already have good scanning tools. The question is, for certain smaller companies with maybe just one single security professional or even a fractional CISO, some of them, they don't even have the right tools enabled. And they struggle to even decide what tools we have to enable. And even if you tell them you have to enable at least open source tool, maybe with certain high rate of false positive, but still at least you have some visibility into your software lifecycle, they still complain, for example, about performance of the build pipeline. So at the end of the day, larger organizations maybe have luxury that they can see all these vulnerabilities and they can enable multiple scanning tool on the pipeline, but that in itself is a decision. And trying to dismiss or prioritize certain vulnerabilities will always be tricky. So the more labels and context we get into these vulnerabilities, the easier it gets to categorize them. CVSS alone, it is useful, but it's definitely not enough. EPSS now makes it easier, at least to focus on what is actively exploited in the wild. But we need definitely more. And we need more not only with CVSS and EPSS, but also on the wider scope of cybersecurity as a whole.
Cool. That's a great way to end. And I'll just add that, and I think that's definitely one of the areas where I think Gen AI and the new sort of tools and bots that allow us to understand what's happening will make a massive difference, because I think they will provide a lot of more scalability in that data. but
Absolutely.
Thanks,
In my
man.
opinion,
Go
that's a double-edged sword.
Oh,
So just to
absolutely.
add
Oh, it's
this,
going to cause a lot of other
so
problems too.
whether we use it or not, the threat actors are already using Gen AI,
Oh,
right?
absolutely. Yeah.
So whether we use it or not, it means that we simply need to catch up, and not necessarily to gain any competitive advantage from defense perspective, right? So we definitely have to leverage Gen AI, for example, with phishing email to recognize a legitimate or illegitimate email, with incident response and logging, checking all kind of network traffic and so on. There are so many ways where AI can be very, very useful. Most important is that we do it, and we do it fast.
Yeah,
Thanks.
absolutely. Well, man, thanks again.
Thank you.
And the recording, really cool. Thank you.
Thank you.